Hello everyone, this is Orhan. Welcome to the K-nearest neighbors lecture. In this lecture, we will be covering K-nearest neighbors algorithm and how we can use it for classification purposes. K-nearest neighbors is one of the simplest and best known non-parametric models. To classify or predict a new record, the method relies on finding similar records in the training data. So we are going to have a test observation x0 and we are going to identify k-nearest records in the training dataset that are similar to x0. And then using these similar records, we are going to classify x0 into one of these classes. So let me give an example. Hopefully this will illustrate the point. Assume that we have two groups of data. The blue points belongs to dogs and then red points belongs to horses. And then x-axis show their heights and then y-axis show their weights. And then we have these three green points whose classification we don't know and we are trying to identify. Obviously dogs have lower height and then lower weight, and horses has higher height and higher weight. Some of these 3 points might be easy to classify. For example, it's obvious that the first point is in the dogs group and the third point is in the horses group, but the point 2 is not easy to identify. What we do is to find the k-nearest neighbors to the record to be classified, which is point 2 in this case, and then using a majority decision rule, we are going to classify the record where the record is classified as a member of the majority class of the k-neighbors. In this case, I am going to find 3 nearest neighbors based on their distance. And by looking at the chart, I see that 2 out of these 3 belongs to blue group, which are dogs, and I decide that point 2 belongs to blue group, which is dogs. So point 2 is a dog. If I increase number of k from 3 to 7, for example, and right now out of 7 I have 5 red points, so we decide that point 2 belongs to red group, which is horses. So point 2 is a horse. Previously, when we chose k as 3, we decided that it's a dog. Right now, we decide that it's a horse. So choosing k changes everything. It matters. So how do I find the 3, 5, or 7 nearest neighbors? Well, basically, based on the Euclidean distance, I'm supposed to calculate the distance, and then whoever is closest to my point, it's going to be the nearest, and second nearest, and third nearest, etc. This method is a non-parametric method because it does not involve estimation of parameters in an assumed function form, such as the linear regression that we covered in the previous video. Instead, this method draws information from similarities between the predictor values of the records in the dataset. Euclidean distance is defined as follows. The distance is going to be the square root of the summation of squared coordinates between the points. For example, if this point is 1 and 2, x is 1, y is 2, this point is x is 4, y is 6, then what we are going to do is to take the differences between the x coordinates and y coordinates and square them. So x coordinate of this point is 4 and x coordinate of this point is 1, 4 minus 1 squared, plus y coordinates. So this is 6, this is 2 here, 6 minus 2 squared. So this is going to be 9, 16. So the distance is going to be square root of 25, which makes 5. The distance between these 2 points is 5. Similarly, we can just calculate another distance. For example, here, look at a B. The x coordinate of point A is 185, the x-coordinate of B is 27. The distance is calculated as the difference between 185 and the 27 squared. Similarly, y is going to be y-coordinate of this point minus y-coordinate of this point squared, and take the square root. So the distance between this point A and this point B is 177 in this simple setup. Think about this question, for example, as a home exercise. So what's the location of all points that are further from A by the same Euclidean distance, say 10 points? What would be the location of all points that are 10 centimeters far from point A? So this is going to be 1 point, and there's going to be another point here, another point here, another point here. So the combination of all these points makes what? So that's the question. So how can we choose k So is it going to be 3, 5, or 10? K is the number of nearby units to be used to classify the new record. K being 1 means to use the nearest record. K being 5 means use the 5 nearest records. Okay, this chart is from an Introduction to Statistical Learning book. In this chart, the K nearest neighbors approach is illustrated in a simple situation with 6 blue observations and 6 orange observations. To your left, a test observation at which a predicted class label is desired is shown as a black cross. The 3 closest points to the test observation are identified, and it is predicted that the test observation belongs to the most commonly occurring class, in this case blue, because there are 2 blue points here. So this is the first one here, this is the second one here. But this point, the third point, is orange. If X would be here, the situation would change. If X was here, the situation would be different. To your right, the K nearest neighbors decision boundary for this example is shown in black. The blue grid indicates the region in which a test observation will be assigned to the blue class, and the orange grid indicates the region in which it will be assigned to the orange class. If the new data that we are trying to predict is here, we are going to say that it is the orange class. If it is here, we are going to say that it's in the blue region. If it is here, again, we are going to say that it's in the blue region. Again, so this chart to your left belongs to the K is equal to 3 classification. If K is equal to 4, the situation, the map to your right would change. If it is 100, it will be totally different. Take a look at this example. Here, we are going to use the same data set. To your left, K is equal to 1. To your right, K is equal to 100. As you can see, K is equal to 100 is a much more smoother line. So if a data is here, this is going to be identified as blue. If the data is here, it's going to be identified as orange. But if the K is equal to 1, the situation is a little more complicated. So the decision boundary is overly flexible when K is equal to 1. But when K is equal to 100, it is not sufficiently flexible. It's very smooth. If K increases, the decision would be less flexible. Okay, so what happens if K is low? What happens if K is high? So low values of K capture local structure in data, but also too much noise. High values of K provide more smoothing, less noise, but miss local structure. So what are the advantages of this model? Basically, K nearest neighbors model is very simple. It works with any number of classes, and we don't assume that anything is normal distributed, and there's no parameters that we are supposed to estimate. We just pick K, and then we are done. So what are the shortcomings? Well, shortcomings are the required size of training set increases exponentially with number of predictors. So in my example that I showed you, in general, I assume that K is equal to 3, and then there are only 2 predictors, X and Y. If there would be 10 predictors, the situation would be overly complicated. And in a large training data set, it takes a long time to find the distances between every single point. And in a large training data set, it would take a long time to find the distances between the points, and these constitute the curse of dimensionality. And the categorical features do not work very well with K nearest neighbors algorithm. How can we deal with the curse of dimensionality? Well, we can reduce the dimension of predictors using, for example, principal component analysis. We covered this in the previous lecture. We might also apply some computational shortcuts. Well, summary. What we did in this class is to cover the K nearest neighbors algorithm. Basically, K nearest neighbors algorithm based on classifying the data set, finding the nearest K neighbors, and then using a majority decision rule to classify the record. The problem is the curse of dimensionality. As number of predictors increases, the situation becomes more and more difficult. Well, if you want to learn more about this algorithm, you can take a look at the Introduction to Statistical Learning, Chapter 2.2 and 4.7, or Data Mining for Business Analytics, Chapter 7. They cover K-nearest algorithm in much more detail. Thanks everyone, and see you in the next Python lecture.